Welcome to EDU World Space.
So in this question, we have a single strain gauge, right? And the angle at point A is equal to 60 degree. Now the strain at this point at point A is negative 250 into 10 raised to power 6, right? The pipe has an outer diameter of 1 inch and an inner diameter of 0.6 inch, right? The pipe is made of the material bronze, and we are required to determine that what are the principal strains, right? So let's start with the solution. Now, as we know that the strain is given by this equation, that is strain equal to the strain in the x direction cos square theta plus strain in the y direction sine square theta and plus gamma xy cos theta sine theta. Right now, what we're going to do is that we have the value of theta that is equal to 60 degrees. So we are going to substitute it over here in this direction, right? And when we substitute it, so we'll get that the strain is equal to 1 divided by 4 times the strain in x direction plus 3 divided by 4 the times the strain in y direction, right? And plus under root 3 by 4 times the times gamma sub xy, right? Next, we need to see that what kind of deformation happens to the pipe because of the force P, right? So it means that the problem is simple enough that we can just look at it and know what we are dealing with and bending and torsion, right? So the equation for these two can be found in chapter 5 and 6, right? And these equations are 5.6 and 6.13. So let me write them down over here. So equation 5.6 is for torsion, right? So that is equal to T times rho divided by J times sigma, right? And this is equal to negative m times y divided by I, right? Now let us start by just the equation that gives us the plane stress, right? The plane stress, that is sigma. Now in that equation, this I is the cross-sectional moment of inertia, right? And y is this I is the, let me write it down, right? So it is the cross sectional moment of inertia, right? And this y is the distance of the point for the region of the axis, right? And m is the moment of force, right? However, in this case, the point A is exactly where the axis starts, right? So it means that um, y is equal to 0. Now, if we solve it for sigma, right? Sorry, my mistake. It's sigma equal to this, right? Now, if we solve it for sigma, that is the plane stress, right? So we get that sigma is equal to m times 0 divided by I, right? And plane stress is equal to 0, right? So it means that if this is the case, so the stress in the x direction is equal to the stress in the y direction, and that is equal to 0. Now, since there is no plane stress, right? So we can say that there is no plane stress. So whatsoever the strain rosette equation becomes, um, strain is equal to 1 divided by 4 into 0 plus 3 divided by 4 into 0 plus under root 3 divided by 4 times gamma sub xy. Right now, since they are being multiplied with 0, so it means that both of these terms, they cancel out, they're cancelled, right? So we are left with only gamma xy into under root 3 divided by 4. Right now, what we are going to do over here is that we are going to rearrange this equation, right? So we're going to rearrange it. So we have gamma sub xy equal to 4 divided by under root 3 into the strain, right? And we have the value for everything. Just plug it over here, and we get that it's equal to negative 5.7735 into 10 raised to power negative 4. That is approximately equal to negative 577 point into 10 raised to power negative 6. Right now, what we are going to do over here is that we are going to use equation 10.9, right? That will give us the principal strains, right? So for principal strains, we are going to use equation 10.9. So we have strain in x direction by the strain in y direction divided by 2 plus minus under root strain in the x direction negative the strain in the y direction divided by 2 whole square plus the square of the gamma um, sub xy divided by 2 whole square, right? So as you can see over here is that there is no strain in the x and y direction, right? So they are basically 0. So it means that this term would be equal to 0, right? And so would be this term. So we will be only left with principal strains is equal to plus minus 577 into 10 raised to power negative 6 divided by 2, right? I've just plugged in the value of this variable, right? And now I'm going to simplify it. So we have plus minus 288.5 into 10 raised to power negative 6, right? And that is approximately equal to 289 into 10 raised to power negative 6, right? Now we are going to write them separately. So the first strain is equal to, we are going to take the positive sign for the first strain. So we have positive 289 into 10 raised to power negative 6, and the other strain is equal to negative 289 into 10 raised to power negative 6, right? So this answer concludes our solution for this